So I want to talk a little more about logarithms. If you are in a Math 96 class and not in an applied class where we get to always use our sweet calculators to do everything, this is a test that I would have a no calculator portion of. And the reason is because to make sure you truly understand what a logarithm is, you have to be able to do simple logarithms by hand. So an example of that would be something like log base 2 of 8. Now, if you think of that using the definition that we had on the last page, right, or that sentence, this basically says, what power do I need to raise 2 in order to get 8? That's what this is showing us. So we go, right? If I raise this to the third power, that will get me 8, right? 2 to the third power is 8. Now, you have two ways you could go about doing this. One is if you're sitting there and you don't know, you have log base 2 of 8 is equal to some value, and that's what you're trying to find. Since that's what you're finding, you can call that x, right? And then you could rewrite this. This would be 2 to the x is equal to 8, right? And that shows you, oh, 2 to the third power, that's 8. Now, this stuff without calculators only makes sense if it works out as a perfect, easy power to actually evaluate. Another way to evaluate this is to think about what that argument is. So log base 2 of 8. Can we rewrite 8 as something? Oh, that's 2 to the third power, right? And now the question becomes really easy. What power do I need to raise 2 to in order to get 2 to the third power? Or I think about the inverse operations on our logarithms and our exponents. The idea that log base b of b to the x is just x, right? And this just gets me out 3. So there are a lot of ways to get to this and show it to you and do this. So I'm going to give you a couple more of these to try, maybe without a calculator, just to see if you would feel comfortable in, say, a Math 96 class. So we'll do something like this. Let's maybe do log base 3 of 9. Let's do log base 4 of 1. So in all of these situations, you're just going, okay, how do I raise 2 to a power to get 1/4? How do I raise 3 to a power to get 9? How do I raise 4 to a power to get 0? So try them out on your own. The more you practice these and doing them in your head, the more obvious or the more understanding you have of what a logarithm is. So I'm actually going to start with one of the easier ones, right? What power do I need to raise 3 to in order to get 9? That one's clearly 2. What power do I need to raise 4 to in order to get 1? Well, if I raise anything to the 0 power, I get 1. The hardest one is this log base 2 of 1/4. Because first of all, we need to end up with a fraction. In order to get a fraction, we need a negative exponent, right? In order to have our 2 to a power end up with 1/4, we need a negative exponent, so 2 ends up in the denominator. And, well, once we realize that that's how we get the 2 in the denominator, it's squared in the denominator. And we can just double check this. 2 to the negative 2, well, that's 1/2 squared, which is 1/4. That's the right answer. This gives rise to some of our properties of logarithms. So I'm just going to write down the big ones that I expect you to know in Math 92. These are the big properties of logarithms right here that I need you to know on the exam. First big property is this idea of how to rewrite. I'm going to put that in the property. So we have our log base b of a is equal to r. So our log with a base of a and a base of b and an argument of a has some result or power, some r, that we can rewrite this as an exponent. The base of that exponential is an b, power is the r, and the argument becomes the answer, right? The second property I want to write down here is that idea of log base b of b to the k power, right? I'm going to make my k look a little better. Since A log is asking what power do I need to raise b to in order to get b to the k. This idea that that log and the exponential undo each other. This is also kind of one of our inverse properties, or the undoing properties, right? Right, if we have a log base b of k, or a b raised to the k power, a log base b will undo that and bring down k. That undoing works in the other direction as well. This one can be a little harder for students to grasp. So I'm actually going to start with my log base b. We'll put k inside of it, or x inside of it. I'll do x this time. And let's say that this is equal to something. Well, I'm just going to leave the something alone right now. Log base b is a power, right? The whole log, this whole thing is a power. It is an exponent. So if it is a power, we can actually go ahead and just make it into the power. And if we choose the base for the exponential to be the same as the base for the logarithm, these two things will actually undo each other, leaving me with just x. So this is also about that undoing idea. So if I have something that's an exponential to start with, I can do a log to undo it. If I have something that's a log to begin with, I can make that the power on an exponential to undo it. It's kind of hard to, this one to me is never as easy. You can use this to solve questions like this one. I'll just show you an example. If we had log base 3 of x is equal to 2, well, we have two ways to solve it. One way is to do this thing. We go, okay, well, I remember this whole thing, a logarithm is really just a power. So these are both powers, both of these sides. So I can go ahead and just make them powers, right? And if I make them powers, since the log and the exponential undo each other, this side just becomes x, and then we get equals 9. And you could even double check that work by just thinking, okay, let me see, log base 3 of 9, does it equal 2? And you just, but at that point, the easiest way when you're checking your work is the second way to solve this question. If you started out with log base 3 of x is equal to 2, I personally would solve this by rewriting it as an exponential rather than thinking of this sort of, I'll write them as powers. This has a little less of the undoing feeling, but that's essentially what you're doing as well. So you sit there and go, okay, the base is 3, my answer is going to become my input, and my input's going to become my answer. So x is equal to 9. So same deal. All right. So those are two properties. We have some more. These three properties are the main ones that are going to help us solve equations. We can either do all of the equations using that first property of being able to rewrite, or we can use the second two properties if we want to think of it more of an inverse operation. Now, there are other properties that we saw. Log base b of any b. Well, that is just a simpler version of the second property, right? What power do I need to raise b to in order to get b? And since there's an invisible 1 here, this is always just 1. It's definitely a question I can ask you on the test. We have log base b of 1. What power do I need to raise b to in order to get 1 out? This is always going to be 0 regardless of the base. We saw that on the other page, right? And anything raised to the 0 power is 1. So b to the 0 power would be 1. What else do we need to talk about? We could also talk about the idea that we cannot have any arguments that are 0 or negative. It is impossible to take b and raise it to some power and get out a negative answer, right? Because our bases are always going to be positive. So it's impossible to multiply a positive number by itself a certain number of times and get out a negative number or get 0. So this will never be possible. Anytime you have that, you're going to have an error. And in fact, we could do some domain questions using that, and I'll do the next video on that.